YouTube channel Mechanical Study, where we study different mechanical systems. So we have already started a question bank series of thermodynamics subject where we have already covered 40 questions. So today we'll start from the 41st question. So question is, a fan consumes 28 watt of electric power and discharges air from a ventilated room at 0.25 kg per second. The maximum air outlet velocity is nearly. So we have to calculate the air outlet velocity, as fan consumes the electric power and converts it into a mechanical energy. So here we can use a formula, that is power is equal to 1 half m dot, that is mass flow rate, into velocity square, that is nothing but the formula of kinetic energy per second. So here just we have to put the value of power, that is 20 watt. Mass flow rate of air is given, that is 0.25 kg per second, and we have to find out the maximum air velocity at outlet. So it comes out to be nearly, so it comes out to be a 12.60 point, and its approximate value comes out to be 12.7 meter per second. So option D will be the right answer for question number 41. The next question, that is, in a reversible adiabatic process, the ratio of T1 to T2 is equal to. So earlier we have also solved such question. So here T1 to T2 is asked, earlier T2 to T1 was asked. So T1 to T2, it comes out to be P1 by P2 raised to gamma minus 1 upon gamma. So option A will be the right answer. And for a adiabatic process, the law is PV raised to gamma is equal to constant, and if you apply for a states, then that is P1 V1 raised to gamma is equal to P2 V2 raised to gamma. So just use the equation, that is PV is equal to MRT. We can get a relation between pressure, volume and temperature. So here for T1 to T2, the correct answer is option A. The next question, that is 43rd question, an isolated system. So there are basically three systems, that is open system, closed system and isolated system. So in open system, mass as well as energy crosses the boundary of a system. In closed system, mass does not cross the boundary but energy crosses the boundary of a system. In isolated system, mass as well as energy does not crosses the boundary of a system. So some of the examples of isolated system are our universe is one type of isolated system. Then a perfectly insulated thermoplast may be considered as a isolated system. So here options are: a specified region where transfer of energy mass takes place, it is open system. It is a region of a constant mass and only energy is allowed, so it is a closed system. Then cannot transfer either energy or mass to or from the surroundings. So option C will be the right answer, that is no mass and energy crosses the boundary of a system. The next question, that is 44th question, that is in a polytropic process. As we all know that the polytropic process follows a law, that is PV raised to n is equal to constant. So if this value of n is equal to infinity, in question they have asked that if n is infinitely large, means n is approximately equals to infinite, then in that case process is termed as, so here v raised to infinity becomes, that is infinity. So here P will be very negligible as compared to the v raised to infinity. So process becomes a isochloric process, that is isochloric process, that is also called as a constant volume process. Now here we can say different processes and value of n for the different processes. If value of n is 0, then it is called as a isobaric or constant pressure process. If the value of n is 1, then the process is called as isothermal process. Then if value of n is equals to 1.4, that is equals to gamma. If the working fluid is air, then the process is a adiabatic process, and if the value of n is infinite, then process becomes isochoric process, that is constant volume process. The next question is the instrument which measures the temperature of a source without direct contact. The options are bimetallic cutout, vapor pressure thermometer, pyrometer, thin film thermometer. So correct option will be pyrometer, and pyrometer measures a temperature in the range 700 to 2000 degree Celsius. So for a high temperature measurement, we have to use a pyrometer. So option C will be the right answer. Then burden for a isothermal process is, so burden for isothermal process, law will be PV is equal to constant. If you solve the equation, that is work will be equals to what? P is equal, W is equal to P dV, and if you integrate from state 1 to 2, so we will get the final answer, that is PV ln of V2 by V1, or PV ln of P1 by P2. So here in option given, that is P1 V1 ln of P1 by P2 and P1 V1 ln of V1 by V2. So option C, it is the answer is right. Option C is the right answer. In option D, it is given P1 V1 ln of V1 by V2. So it is not V1 by V2, it is V2 by P1. So this will be the correct answer. So option C will be the right. The next 47th question: which of the following is correct statement for energy? Now, so first option is energy is not a property of a system, but so it is not right. Energy is a property of a system. The next, energy is a path function. It is not right. So it is, energy is a point function. Then change in energy between two states of a system is different for different path followed. So energy is a point function, so it does not depend upon the path followed. So irrespective of any path, if the points initial and final points for the process are identical, then change in energy will be same irrespective of any path. So it is not true. Then option D is that the cyclic integral of change in energy will be 0. So it is true. So option D will be the right answer. As it is a point function, that is the reason why its cyclic integral becomes 0. So yeah, that is any point function. For any cyclic integral of any point function, it is always equals to 0. The next question, that is internal energy of a system containing perfect gas depends upon. So internal energy, earlier I have told you also that the internal energy is a function of a temperature, and change in internal energy is nothing but that is mc dt. So it depends upon the temperature of a gas or a system. Next question, which of the following equations is correct? So where V, P, T and Q are volume, pressure, temperature and heat transfer respectively. So cyclic integral of del V is equal to 0, then integral of dP is equal to 0, then integral of dt is equal to 0, and integral of dq is equal to 0. Now from above, volume, pressure and temperature all are point function and Q is a path function. So as you all know that the any point function, its cyclic integral comes out to be equals to 0. So for option A is that is dV, cyclic integral of dV equals to 0, it is true. Then dP is also true, then cyclic integral of dt is also true. Now here question asked is that the which of the following equations is incorrect. So incorrect will be the cyclic integral of del q is equal to 0, because it is a path function. Its cyclic integral never to comes out to be 0. It is an inexact differential. Inexact differential means in the sense like we can write delta p as p2 minus p1, but we cannot write del q as or delta q as q2 minus q1. That is the reason it is called as inexact differential. The next question, that is 50th question, which of the following statements is correct for energy? So it is a point function, so it is a correct answer. It is a path function, it is not true. It is not a conserved quantity, again it is not true. It can be measured by thermometer. So basically temperature is measured with the thermometer, so energy is not measured with the thermometer. So option A will be the right answer. So 50th answer will be the option A. The next question, heat capacity of a substance is given by. So heat capacity of a substance is given by, that is m into specific heat, that is mass into specific heat. So here option C will be the right one. Option C will be the right one. The next question, that is which of the following is not an intensive property? So intensive property are those properties which are mass independent, and extensive are mass dependent. Here temperature is intensive property, pressure is also intensive property, energy is not an intensive property, it is an extensive property because it depends upon the mass of a system. Then specific volume is an intensive property. Then specific energy is also an intensive property because it is measured with respect to per unit mass of a system. So answer C will be the right answer, that is it is a extensive property. Then question number 53, a piston cylinder arrangement has air at 600 kilopascal to 90 Kelvin and volume of 0.01 meter cube during a constant pressure process. Now the process is constant pressure process. If it gives 54 kilojoule of work, the final volume must be. Now here pressure is constant, so you can use a formula, that is W is equal to P dV. So Here pressure is constant, change in volume, that we have to find out the final volume. So W is equal to, can be written as P V2 minus V1. Here we have to find out V2. So just put the value of W, that is how much it is. W is 54 kilojoule. Then pressure is 600 kilopascal. Then V2 we have to find out, and V1 is 0.01 meter cube. So put that values in the equation and we will get the final answer, and it comes out to be a 0.1 meter cube. So final volumes comes out to be 0.1 meter cube. So option A will be the correct one. So option will be the correct one, and we have to solve with the this solution, that is on your screen you can see solution of this that I have already told you. The next question number 54, the polytropic process with n is equal to -1 initiates with the P pressure and volume equals to 0 and ends with pressure and volume equals to, pressure is equal to 600 kilopascal and volume is equal to 0.01 meter cube. The work done is, now formula for the work done for the polytropic process is nothing but W is equal to P1 V1 minus P2 V2 upon n minus 1. So this is the formula. This is for the polytropic process. If it is adiabatic process, then n is replaced by gamma. So just we have to replace n by gamma if it is a adiabatic process. Here the question is for polytropic process. Here initial pressure and volume is 0, so it is come out to be 0, and final pressure is 600 kilopascal and volume is 0.01 meter cube. So just we have to multiply this and divide it by, that is n divided by minus 2. So final answer comes out to be, if you put all those in equation, final answer comes out to be 3 kilojoules. So option B will be the right one. Work done in a pre-expansion process, again in a pre-expansion portion work done is 0. So option C will be the right answer. For an ideal gas, enthalpy is represented by, so enthalpy is basically nothing but a sum of internal energy plus flow work, which is nothing but pressure into volume. Or a specific enthalpy is nothing but H plus P B. So that is a specific internal energy plus specific flow work. So here we can write this as a, so here this term, that is here H is equal to U plus, it is given that is RT. So in option B you can say that is H plus RT. So here we have to just use ideal gas equation, that is PV is equal to MRT. So this will be the thing, that is instead of PV there will be a RT. So here final answer will be option B. Which of the following represent the energy in storage? So there are different terms, that is options are work, heat, energy and internal energy. So internal energy is called as the energy in storage. So option D will be the right answer. The heat transfer takes place as per, option A is 0th law of thermodynamics, option B is first law of thermodynamics, option C is second law of thermodynamics. Okay, so option C will be the right answer. So heat transfer takes place as per the second law of thermodynamics. There are basically two laws of thermodynamics. Two statements of second law of thermodynamics, that is Kelvin-Planck statement and second is Clausius statement. Kelvin-Planck gives us a statement about the heat engine, and Clausius gives us a statement about a refrigerator or a heat pump. The next question, that is question 59. 2 kg of substance receives 500 kilojoule and undergoes temperature change of 100 degrees Celsius to 200 degrees Celsius. Then average specific heat of substance during process will be. So here the question asked is to find out the average specific heat. So one thing must be known, that is that is there is sensible heat transfer. It can be measured with the help of MC dt. Here mass is given, that is 2 kg. Then Q is given, that is Q is equal to 500 kilojoule, and it undergoes a temperature change, that is 100 to 200. So we have to just put the value of Q, that is 500 kilojoule, mass is equal to 2 kg, then dt is equal to 100 degrees Celsius. Then we will get the C, that is the average specific heat, and it comes out to be 2.5 kilojoule per kg Kelvin. Its unit is kilojoule per kg Kelvin. So specific heat comes out to be 2.5 kilojoule per kg Kelvin. Now what is specific heat? Specific heat is nothing but the amount of heat required to raise the temperature of any substance through unit degree Celsius or unit degree Kelvin. So this is the definition of a specific heat. Then last question for today's lecture, that is the work done during a isothermal process. That is the process given is a isothermal process. So here work done during a isothermal process is, earlier I have told you, that is P1 V1 ln of V2 by V1 or P1 by P2. So here in option we can say option A, that is a log to the base E here. So it is in simple, it is a term as ln, that is V2 by V1. So option A will be the right answer. So this is all for today. So do like and subscribe to my subscribe to the channel. Thank you.